Hello, hello to all cloud builders on the air and those who watch us in recording. It is awesome day here in Odessa, and I think there is no reason to be depressed with the cold breath of winter. Here, in Cloud Builders community, we create a soft and cozy atmosphere. We invite you to grab some hot tea or coffee and meet friends from Java development industry. Before I invite our amazing speakers, let me introduce myself. My name is Artem Trofymov. I am software engineer at Oracle with interests in building distributed software systems and networking with passionate colleagues like you. Today, I'm your host of this meetup. For those who join us first, here is a short introduction to our Cloud Builders community. We are a community for learning and inspiration. Our online events are headed by leading industry experts. Community members get free access to all our build-ups and records. And now, let me continue with the agenda for today. As I mentioned, the build-up will be devoted to Java, featured with stage talks and fireside chat. In a few moments, we will enjoy the first stage talk, Cloud Native Quarkus, by Roberto Cortez from RedHat.
Hello.
Hi, Roberto.
Hi, Artem. Really nice
Nice
to
to
meet
see
you.
you.
Yeah, thank you
Let me
so much for having
continue.
me here.
Let me continue to introduce the rest of the agenda, and then we will continue with your speech. Thank you. After Roberto's speech, we will take a short break, maybe 5 minutes or so, and then Denys Fedenko, our expert from Intellias, will lead a lightning talk, Is EV a future? Automotive market trends and the role of Java in it. After the talk, we are going to have a great fireside chat, modern Java features with Nicolai Parlog from Oracle. During these talks, we will answer your tricky questions. Don't hesitate to ask them in the Slido application. Even if you don't plan to ask something, it's still worth to open Slido to vote for your favorite topics. Today's speeches are being recorded, and organizers will send the links to video records to your emails in a few days. So don't worry in case you missed something. We will be glad to see you on our Telegram channel. You can find link in the description here. And for sure, subscribe to this YouTube channel. Are you ready? Drop here in chat. What do you expect to learn during Build Up Java Edition? And greet here on the YouTube chat our first speaker, Roberto Cortez. Here's your turn to.
Hi, I mean, so much enthusiasm. I'm not sure if I can take that. Well, I'll try. Yeah, so thank you so much for having me here. It's a real pleasure to be here with you today. And I hope the audience has a good time listening to all the amazing talks that you schedule for them.
Thank you. Have a good time speaking. Enjoy and good
Okay,
luck.
thank you very much. Okay, so hi everyone. My name is Roberto. So thank you so much for joining this session. As Antal mentioned, I'm gonna talk a little bit about Quarkus. Maybe you have heard about that, maybe you haven't. But my plan for the session is to just make like a quick introduction, talk why Quarkus can actually help you into the cloud if you even if you already have some cloud applications or if you're planning to move to the cloud, and then hopefully I'll still have some spare time uh, to do a couple of demos so you can actually see Quarkus in action. Um, so let me actually go and go to my slides and share the screen. So hopefully everyone is seeing the slides. Can you confirm? Hello? Just to make sure. Okay, wonderful. Yeah, just wanted to make sure that the slides were okay. Um, and yeah, so for Quarkus, guys, so for Quarkus is, if you haven't heard about Quarkus before, all right, so Quarkus is a completely open source stack that you can use to write any kind of Java applications. It can be things like Cloud Native, microservices, and serverless, of course, which tie more closely to the cloud. Now, as you're going to see for the presentation, there are other cases where you can use Quarkus. So Quarkus is not only for these cases. You've seen Quarkus being used to write command line applications or even monoliths. So it's not really limited for these use cases, but um, those were like what we had in mind when we designed Quarkus. Now, of course, the second question that comes up is, okay, why Quarkus? I mean, why another stack? Why another Java stack to write Java applications? There are already a bunch of them out there, and they're amazing. They're great. But we believe that Quarkus can offer you a few different things that I'm going to try to make clear during the presentation. Now, to answer the question why Quarkus, we have to look into a little bit on how the JVM operates and how it works and how it actually has some impact when you're running things, not only in the cloud, right? This also applies into bare metal, but when in the move on the cloud, this became a little more obvious and a little more evident, right? Now, when you look into a JVM process, there's always going to be some kind of overhead involved, right? So it's going to be an overhead when you're going to start the application, right? So your application not always gonna is not gonna instantly start. So there's going to be a overhead when you have to load stuff from the application so your application can run. And there's also memory overhead with things that they are required in memory that they're going to occupy your memory, right? So these two things are actually important because those those of course are going to impact your cloud prices or your what you have to pay for your cloud provider in the end of the month, right? So usually when you look into cloud providers, you have things like you have to pay by CPU, you have to pay by memory, and when you start to look into things like this, well, and you have to scale with a bunch of nodes, then all of these add up, and well, this is going to be somehow relevant. Now, this is not only relevant for the cloud, right? So else is also relevant when you compare Java with other technologies like Node and Go, right? So of course, this graph here is not at the scale, but I think we can clearly agree that when you, if you know the and Go applications, that they are really less memory hungry than Hotspot Java or any other JVM runtime. Of course, I'm not trying to start a debate here on what's best or what is not. And of course, there are reasons why these sort of things happen. But and I'm not gonna go into that because that's like a completely separate discussion. But that's just the fact that we have right now, right? So if you pick Java as your primary runtime, of course, you're then gonna require more memory compared to other technologies. And well, here on the Java community, especially on Quarkus, we want our users and we want developers and the community to be able to compete with other technologies without having to lose anything that Java gives to them, right? Now, on the Quarkus side, the idea is that we were trying to come up with some sort of platform that is able to or can try to compete with things regarding on memory on the CPU as Node and Go. Even if you compare it with traditional native stacks, our idea is that you're able to fit way more Quarkus nodes than you're able to fit as a traditional Java stack. Maybe think about a Wildfly, Jakarta E server, or even a Spring. And I love those technologies; it doesn't really matter. But in here, we're just discussing a little bit of resources. Now, of course, discussing resources, that's great, and you might be asking, well, how were you able to accomplish that? And I'll get into that as well. Now, we also realize that just coming with the resources argument, it's not completely enough to convince people to move, right? So if you just say, oh, we just use less memory, less CPU, well, for some people might be interesting to change, but maybe for some that's not that interesting. So we also try to offer a couple other things that are more developer oriented, so people can actually see and try to be more productive on a Quarkus platform, right? Now, one of the first benefits, and that's one of the or centric messages that we want to pass, is what we call developer joy, which is we try to come up with the platform which is like zero configuration. It's based on standards, and it is streamlined for most of the code that you're going to write, and then there are like some extension points and flexible for the rest ones. Um, and we support things like hot reloading, right? So, and hot reloading actually works. So you can actually change your code and see the change straight away, just hitting refresh. There is no redeploy involved. There is no restart involved. So it's just like you start Quarkus and then you type your code and you just go as you long, and you see all the changes you're doing on your on your application without any restarts, without any redeploys, which is actually one of the features that our users really enjoy. So all of these is to try to make um, users more productive. Now, of course, the other one that I did mention first, but now looking a little bit more detail, is about all of these memory usages and CPUs. Now, if you compare it with a traditional native stack, we may be thinking about 130 meg. That's some of the measures, right? Um, for Quarkus, we observe things like half the size. And if we compile Quarkus to use GraalVM with native mode, you even see a tenth of the size, right? So I'll get into GraalVM and native mode deeper into the presentation, so not worry about that right now. But at least you know there is that option, and you see that those numbers are quite impressive. Now, if you pick like a more detailed application, and we're calling here like a REST plus CRUD application, so it has like some REST endpoints, an API, database access, right? So you'll see more memory usage on the traditional native stack. So it's not half the size like it was before, but still a considerable amount of less memory. But again, if you look into native mode, you see like a tenth of the size. So that's pretty much linear with our metrics. And again, it's quite impressive to see, in my opinion, this application of 20 meg or almost 30 meg in size for the amount of what you can do, right? You observe the same things for the startup times, right? So you see sub-millisecond startup time with native mode, and even if you're running Quarkus with JVM normal mode, you see like just a couple of seconds, right? While it's not really unusual to see all traditional Java stacks take 10, 50, 20 seconds to start, right? So it may not seem much, but I mean, for us developers, we are a little bit impatient, right? So everything that slows us down is going to distract us. So if we can go as fast as we can, of course, we're going to choose that route. Now, one other trend that's really popular these days is all the reactive movement, right? And of course, Quarkus is also capable of doing all the reactive stuff, but we do it with a twist in the sense that we try to reuse the exact same APIs that you will use to do imperative or reactive, in the sense that you can even combine both. And if you just want to switch from one to another, you have to just switch a dependency, and that's pretty much it. You don't have to rewrite your application to be fully reactive. You can just pick to use imperative in one situation or reactive in the other. And of course, there are a couple of APIs that might be different well, because of the nature of reactive. But as you can see, for those example, for these couple of examples of these two REST endpoints, they're not really that different. So you still use the same annotations. The response types is different, of course, because that's a reactive endpoint, but it's pretty much the same. And one of the interesting thing is, if you haven't start working with Quarkus, we have like this joke where, well, Quarkus kind of launches maybe like 2-3 years ago, but maybe you have like 7 or 8 years of experience with Quarkus already. And the reason for that is Quarkus is built on top of the most popular and the best frameworks and libraries out there from Java, right? So most likely you're going to recognize some of these logos like Camel, Hibernate, REST-easy, Vertex, OpenShift, Kubernetes, MicroProfile, Kafka. So all of that comes out of the box in Quarkus. Even for Spring users, we integrate directly with the Spring APIs, and you can use the Spring annotations in Quarkus and build the REST endpoint just like that. Now, to try to, really seems too good to be true. Now, I'm gonna go a little bit deep into Quarkus so you can actually understand the architecture, and you can actually realize how Quarkus can do all of these for you. Now, probably you already figured out how traditional applications or traditional frameworks start, right? So usually you write your code, and then you have some kind of build tool like Maven or Gradle, and then you build your application. You either output like a WAR file or a fat jar file, doesn't really matter. And from that point forward, that's when a lot of the operations are going to occur. Then you have to deploy it and run it somewhere. It can be like bare metal or cloud. Now, when you run this application, then there are a lot of things that are going to happen, right? So maybe you have to load some configurations files. Then sometimes you have like some class path scanning happening to discover the classes that you wrote with some particular annotations that are going to create like a REST endpoint. And then there is like this meta model build that the application has to start. So you think, for instance, things like Hibernate, where you have your entity model, right? So Hibernate has to represent that entity model somewhere somehow. So usually that's one example. And then you have thread pools being started. So there are like a bunch of operations that happen when you run the app. Now, on the Quarkus side, we tried to shift this a little bit and try to come up with a way to do to build these applications and to reuse some of this logic that happens during runtime, which is when you're starting the application, to actually start only during the build, right? Now, that is going to, of course, give several benefits. But one specific example is, let's just say that you have to read an XML file, then you keep the representation in memory because it is the configuration of your application. Well, that's something that can happen during the build, right? So you build the application, read that configuration file, then you can just store the data in that's what we do actually. We store data in a particular format, and then when the application starts, we'll just read the data from there directly, and then we don't have to go and read the XML. A couple of other examples is when you have like all of these libraries like Hibernate or REST-easy or even Spring, all of them are going to do some sort of class path scanning to find whatever they need. And sometimes it's not really uncommon to see like 6, 7, or 8, or even more scans to the class path for libraries to find stuff. Now, another thing that we do is we just unify all of that into a single scan. So there is like a dictionary that we provide, so libraries can find what they need in a single go. So that also saves a lot of time. Now, what are the benefits that you get from this? So we try to move as much as possible from the runtime to the build phase, right? So not only this is going to save time when you're running the application, when you're starting up the application, but also it's going to reduce the number of dependencies that you're going to have on the runtime. So if you pick that example that I gave earlier about reading an XML file, well, if you already read the XML file during the build, then you don't need the XML parsers anymore. You don't need the XML schemas anymore. So you can just throw all of that away, unless of course you're reading them on runtime. But that's what you're trying to avoid. So by removing those dependencies that you don't need anymore, you're also saving memory. And this is what we do by maximizing all of this dead code elimination. So we see what code's being run, what code it is not. So to remove all of that, and we also do some reflection based code to remove all of the reflection based, or at least try to remove as much as we can. And these optimizations benefit both GraalVM and traditional hotspots or the JDK. Now, why is it relevant when we're talking about a cloud infrastructure? Now, if you think, let's just say you're running your application in the cloud and you have to scale to 100 nodes, right? And now you have 100 nodes that take like 10 seconds to start. So all of those numbers are going to add up. And if those 100 nodes take 200 megs as well, in the end, you're going to have like a big chunk of money that you have to pay to your cloud provider. Now, if you're able to run an application that takes less time to start and takes less memory, of course, that's going to be better for your wallet. And maybe the cloud provider is going to be very happy about it, but it is you that has to be happy, right? Now, if you really think about it, this makes perfect sense. It doesn't really make any sense to have 100 nodes when they're starting up. They do the exact same operations, right? It's the same application that's being started. It's the same version of the app. So all the operations that are being done are exactly the same. So it's completely wasted time, completely wasted resources to do that in 100 nodes or even more, right? So it doesn't really matter the number of nodes. You only need to have 2 to make it a waste. So if you try to move, or if you move all of the common things that are required to build time, we're saving a lot of stuff. So yeah, so these are just a couple of examples. So I think so this is the core idea of Quarkus. I think it's really easy to grasp, even though I haven't show how it's actually implemented. And then, well, I'm not going to show that. It's open source. You can go and check it out how it's done. But I think you're able to understand what the core principle is, and once you understand that, then it's pretty easy to also say, okay, now I understand why you're able to save X amount of memory or X amount of CPU or whatever, because this makes perfect sense. And yes, of course, it is not random vaporware that you're just throwing us. This is actually real. So to summarize this a little bit, the idea here, of course, is trying to do the work once and not at each start, right? So we try to move as much as possible during the build. So a lot of the classes that you actually use during the run, they are not needed anymore. So you can just throw them away. So that's less memory. So less time to start, less memory usage, and there is no reflection. There is no dynamic proxying involved. So you're gonna benefit not only an application that is faster and less memory, but also you're gonna have an application that's gonna be faster as a whole, even during runtime. Now, all of this is provided by Quarkus extensions. So Quarkus extensions are actually the magic bit that contains the logic that provides how Quarkus works. And the idea here is that we pick a library, let's just say Hibernate, and we build what we say like a Quarkus Hibernate extension. And then we force, in a way, we force Hibernate to behave how Quarkus expects it to be, right? So there are like a bunch of extensions already out there. So they cover all the popular libraries, and you can even make your own. Now, this is just to tell you that Quarkus is compatible pretty much anything on the JVM. So you can use whatever library that you want. Now, if you want to really benefit what Quarkus gives to you, you have to go for a Quarkus extension. So for instance, if you use the regular Hibernate dependencies, because it doesn't have all of these that we've done for you, then you're not going to benefit for all the memory improvements and CPU improvements that are out there. So you always have to go for the Quarkus extension to be able to achieve that. Now, maybe you heard other things about Quarkus saying that, well, it's just for small applications or just for Kubernetes or just an heavy compiler. And yes, all of those are true, but I think Quarkus is way, way more than that. So yes, Quarkus is definitely not just an heavy compiler. Of course, it works great with GraalVM, and that's one of the things that I'm going to talk to you next. It's not only for REST, so you can build it for any kind of applications. You can even build monoliths with it, so it's not only for microservices or serverless. And it's not only another framework, and we're not trying to copy what Spring does. I believe Spring is a great technology. They're great, but Quark is trying to do its own thing. Okay, native image. So I did mention that you could run Quarkus as a native image. So let's see what exactly does that mean, right? So if you heard, maybe you heard, maybe you haven't. So there is this really interesting project called GraalVM. It's coming from Oracle Labs, so it's already like maybe like 4 or 5 years old, maybe more, maybe 6. I can't remember exactly. And GraalVM ships with something really cool. It's called native image, which basically allows you to inspect your application. You actually feed it a jar file or whatever, and then you can actually output a completely binary target from that jar, and you can just run it as you run any binary application, right? So once you have a binary image, you don't run it in Java anymore. So you wrote it with Java, but it doesn't run as a Java application. So instead, you have something called Substrat VM, which is the VM that comes with GraalVM as well, which is the one that's built into the image executable for you to be able to run the application. Now, this seems again, this seems too good to be true, but there is like a dark side of this, right? So, and the dark side is, well, it's not Java that you're running, so there are like a bunch of limitations on the GraalVM native image mode side. So things like dynamic class loading and or invoke dynamics, security, those are not supported at all, right? And other things that are supported, they have like several limitations. So for instance, reflection. Yes, reflection is supported, but you have to tell exactly what GraalVM requires to call your classes or methods by reflection. So you have to say, I want to call this method by reflection. So the GraalVM can include it into the binary. If not, then GraalVM doesn't know exactly what's going to be required, and then going to have to include everything, which is not very interesting, right? So when we also started the Quarkus architect, that was also with the GraalVM in mind, right? So that was one of the also another reasons why we had to do all this work of moving things from the runtime to the build time to be able to cope with the GraalVM limitations, and then you being able to compile your application to native. Now, you also may be wondering, well, yeah, well, you have Quarkus, you can run it on the JVM mode, so you can run it in Java as you run any other application, it behaves exactly the same. You can run it in native mode with GraalVM, so it's going to behave exactly the same, at least that's our guarantee, right? And well, there are multiple use cases where you want to use one or the other. So you may be thinking that you may want to use the GraalVM all the time because, well, it's smaller and use less memory and less CPU. And yes, that's correct. But for instance, the JVM mode is still gonna beat the native image in a lot of other scenarios, right? So if you have requirements that you require high memory density, and then you require the best raw performance, right? The JVM is still gonna beat the native mode. But if you have things like serverless, right? If you're really need to start like a bunch of nodes really quick to answer like a burst of requests, then the native image is actually good for you. And I mean, when you're running multiple nodes, you can even combine both, and you have like a couple of JVM nodes and a couple of native image modes. It's completely fine. Okay, so I think that pretty much covers a little bit what I wanted to tell you on the theoretical side. So let's try and go and do a couple of demos and show a little bit about Quarkus to you. So let me go and switch here to my IDE. Let's put this a little bit bigger. Oh, are we done with time? Oh, I thought I had like 40 minutes. It's fine. Okay, apparently we don't have any time for demos. Thank you so much for seeing my presentation. I'm not sure if you have any time for QA. If we do, then I'm happy to answer any questions that you might have.
Yes, Roberto, thank you for your presentation. You have rocked our virtual stage. And yes, we have time for the questions. And now our participants and I want to ask you something. The first question is there a future for monoliths or microservices will shape the agenda? What's your opinion?
Well, I
Play.
believe I believe that both are still viable options, right? So microservices, they are not come for cheap, right? So they're not free, right? The uh, if you look into the industry and yeah, I'm not sure if all of you are aware, but they were heavily popularized by Netflix, so that's why you see a lot of the Netflix libraries out there that they actually had to build to support them, right? Um, so other things like monitoring, logging, telemetry, right? So because I mean, one thing is you have a monolith where everything is running together, and either it's kind of like a binary, it either runs or not, right? When you see like a bunch of services running around, right, you don't know exactly what's going on, right? So the amount of effort that's required to support a microservice architecture is actually bigger in my opinion, and it's a little bit more complex. And of course, there are all the benefits that you get because then you are able to scale things individually, right? And then you can split the work. Uh, but uh, but
But if
in
we
the
talk
end,
about Quarkus, do you see Quarkus is good for monoliths as well? Because it's definitely
definitely,
great for microservices.
definitely. I mean, Quarkus, of course, was built with microservices in mind, but I mean, we've seen people building monoliths with Quarkus as well. So all the principles that I mentioned over here, while they'll definitely fit very well with microservices, they are not exclusive to a monolith, right? So you're still going to have all the issues that we had before with like memory usage and CPU usage, right?
Mhm.
So that's also going to be present on the monolith. So you're still going to have the same benefits you'll get on a monolith, whether
I see.
you'll
I
get
see. We
on a
have a number
microservice.
of questions, so let's switch to the next. Okay.
Sure.
It's thank you for your answer. Vyacheslav asks how to save time on Quarkus native compilation in CI. Do you have some suggestion?
Well, there are some command line arguments that you can use, but I actually won't be too concerned about it, right? So it is a CI. It's something that is like asynchronous, right? That's the idea with the CI. And I mean, there putting more CPUs and memory, of course, also helps. And for instance, if you're using things like GitHub Actions, which have like limited amount of resources, things are going to take a little longer. But I mean, um, the native image build is always going to be slow, and the GraalVM team is working to improve that, but it's not going to beat the Java compiler, right? Because those are completely different things. You have to remember that when you're passing in a native executable building, it's kind of like building a C application where everything has to be like analyzed in line, has to be eliminated, right? And when you're building a Java application as a regular jar file, you just basically it's just like a transpilation from the Java source to bytecode, and then it's actually the JVM that does the bytecode interpretation. So those are completely two different processes, and I mean, there is no really big way to actually match both in the sense that the native compilation is going to take the exact same time as a regular Java compile. That's simply not possible. But there are, if you look into some of the Quarkus guys, you'll find, I don't know them by memory, all the command line arguments, but you'll find some things that you can put there to shave some time off.
Mm-hmm. Mm-hmm. Thank you. And there is a question from Valera Dobrodev. Maybe you know about CentOS development plans. It's somehow related to your employment in Red Hat. I'm not sure if you know, but if you have any news.
CentOS development?
Yeah.
Yeah, sorry,
CentOS
that's not.
development plans.
Yeah, sorry, I don't think I don't have any word on that.
Okay. Okay. We have also a question about synchronous and asynchronous way to develop something. So Zen and Igor are asking, what is the best way to do background task for maybe some mobile application, either to do sync or async or some trading or some services? So we have
I
some
mean
suggestions.
that's always going to depend on the things that you're doing, right? So my usual take on that is you start with synchronous because that's usually easier. Even though the APIs on Quarkus, we don't make any distinction, and you can use the same exact APIs for both. But I say easier in the sense of debugging, right? Um,
Mm-hmm.
because it's always going to be easier to debug a synchronous application than a synchronous one. And only if you start seeing like things like performance degradation or things that you have like, let's just say you want to build like this huge report that's going to take like a long time to execute, right? Then of course you're not going to make that synchronous to the user. You're going to make that asynchronous, right? So it really depends on the use case. But my general take is start synchronous and only change to asynchronous if there's really a strong reason for that.
Thanks, it's clear. Another question is also kind of flame. Spring Boot versus Quarkus. Why Quarkus and what are the pitfalls?
Well, I mean, we're not trying to compete with Spring. I mean, I've used Spring in the past. It's a great technology, right? And I love the Spring, and of course, I what I believe, and I'm gonna be try to be very diplomatic here, is I think that the community has to gain when you have like multiple choices and when you have uh, multiple things that are trying different things together. In the sense that imagine a world where you only have Spring Boot, right? And we sometimes at some maybe a few years ago we only had that world. So yes, they made a lot of innovation, but at the same time you didn't have different things to try out. Now, for instance, if you look into Spring, they're also supporting things like building build time compilation and native image mode, right?
Yeah.
And maybe they took that idea from Quarkus. I don't know. I'm just speculating. But what I'm trying to say over here is I think it's better if you have like multiple frameworks where they can try to push each other to have more innovation than have like a single one where then it doesn't feel there is any competition and then innovation may fall out a little bit.
Yeah, yeah, definitely. Okay, there is three questions from myself.
Sure.
What languages does Quarkus supports beside Java? What dependency injection is used in Quarkus? And how to configure application properties for different tiers like dev, QA, stage, prod?
Okay. So there are three questions over there. Let's see if I got all of them right. So what language we do support? So we support Kotlin, Scala. So any pretty much all any Java, any JVM language works. I mean, it's Java, right? So it works with Quarkus. Now, for instance, things like Groovy, which rely heavily on things like invoke dynamics. We don't. Well, you're able to use Groovy with with the JDK and the JVM, but then you're not able to compile Groovy to native. So that's
Mm-hmm.
a limitation
It's
on the
clear.
Groovy side.
Yeah.
The other one for injection, so we
Dependency
use
injection.
CDI. We use CDI. We have our Quarkus has its own CDI implementation. It's called Arc, and well, it works exactly like you could expect with GDI with that inject, and it works like well than what you'll find into Java or Javax or Jakarta now frameworks. And for configuration, so you have application.properties file. That's the main configuration file. Have this notion of profile, right? So you can pass what we call the profile to run your application using quarkus.profile equals something, and
Mm-hmm.
you can say you can run your application in dev mode, in prod, in test. So it's just an arbitrary name. And then if you want to have like different configuration for different profiles, you just name your application properties file as application dash profile name dot properties, and then when you
Mm-hmm.
activate that profile, that file is also loaded, plus the application dot properties file, but one on top of the other.
I
So it's
see.
kind of like a layer. So if you're running
Mm-hmm.
Quarkus in their profile, for instance, then you have application dash dev dot properties being loaded, and then you have application dot properties being loaded after the dev one. So basically, you actually only have to place the configuration that you want to override, and you don't have to duplicate all the configuration. So it's actually works as layers where the the, the layer that builds on top overrides the one on the bottom.
Mm-hmm. I see. Okay, and the last question, it's actually consists of several from Victor.
Sure.
Can you recommend some some materials for studying Quarkus? Also, there is a question about module system in monolith project. I don't know if there is some specific, maybe you can highlight it. And using Guava and updating it to newly versions in Quarkus. What do you think, if there is any pitfalls?
Okay, so those three questions again. So the first one, materials for learning Quarkus. So the first one that I suggest is to go to the Quarkus website. So you go quarkus.io. You have several tutorials, several reference guides that try to guide you for several use cases. So saying you how to build a REST endpoint, how to build a Kafka queue, how to secure your endpoint. So you have all of those examples and tutorials and guidelines. There are also a couple of books. You can find, I don't remember the name of the book right now. I can try to dig that up, but just try to search Antonio Gonçalves, which is a close friend of mine. He wrote a Quarkus book, so find Antonio Gonçalves Quarkus book and you'll probably find it. I
Mm-hmm.
can highly recommend that book if you want to give it a try. Um, so you can start for those resources. So sorry, what was the second question? I forgot. Was
Second
about Guava
question
or
was
the model
about
system? Ah,
yeah, module system.
yeah. So Quarkus itself, we don't support Jigsaw or the model system yet, just because we haven't found any use case um right now for it. We haven't seen people asking for it anyway. So that's something that right now we don't support. We have no idea if we're going to support that in the future. But please feel free to come by GitHub. So Quarkus is an open source project. You can go on GitHub, you can open an issue and say, hey, I think you should support the model system for whatever reason. Here's my use case, and for sure we'll have a look and analyze it. But for now, we haven't found any compelling use case to actually have to implement that.
Okay, and the
The
last question for today. Sorry, we are running out of time. There is still one more question, and
Sure.
it's from Roman Bespalko. Is it possible to use AWS Lambda alias name as profile name for configuration? Currently, it's blocker for him to use Quarkus.
I have no idea. I'll have to check it out. But I think you're asking. I mean, I actually write all the configuration implementations on Quarkus. So if something's missing on the configuration side, feel free to open an issue, and I'll happy to have a look into that. I haven't looked into the AWS stuff, but if that's a blocker, please come to GitHub, open an issue. You can even mention me directly. My username on GitHub is Rad Cortez, an R, an A, a D, and Cortez, and I'll be happy to look into that.
Great. Thank you for all the answers to our questions.
I mean,
It was great presentation.
It was awesome, the questions. I'm really happy with all the QA that we got. So thank you so much for that as well.
Thank you, Roberto. See you. And actually, we were going to have a short break. So there is a question to you, cloud builders. Are you impressed? Leave your opinion in YouTube chat. And we will meet you after the short break, maybe 5 minutes or so. And see you soon. Cloud builders, we are back. Are you ready for new Java revelations? What's next? I'm introducing to you our second speaker, Denys Fedenko. Denys is the delivery manager of the Automotive segment at Intellias. Here are important insights about Denys. He has 8 years of professional experience in IT. He currently specializes in navigation and automotive stack, and he will lead a lightning talk on the topic, Is EV a future? Automotive market trends and the role of Java in it. Denys?
Thank you for joining this meeting, and thank you for asking me to be the part of that. My speech will be the much less technical one, but I will try to make it really short. I will cover in 15 minutes. I will try to explain you the more discussable, even the point, about the future of automotive and is it really EV. And I will try to present you what is like Java involvement in that, because usually automotive it's not something what when you can hear Java and automotive it's not really something what attached to each other from opinion of market, but from my experience it's not really true. So yeah, as far okay, my presentation just stuck. All right, just give me a second. So yeah, now it works. Let's go super fast. Yeah, thank you for introduction. I will skip that. As far as I am somehow related to automotive, I'm the one who will try to present you the topic. Why Intellias? Because we, as a service company, have a lot of projects and clients who work in automotive area. And the interesting point that we can see the bigger picture even than some automotive OEMs, because they're really focused on their goal, and we are working with different areas, with different suppliers, and as a result, it's provide for us the possibility to see the bigger picture. So as you can see on this screen, we have really a lot of projects in different areas like autonomous driving, navigation, embedded development, etc. So that's why I can say that I can feel and see is a really big understanding of the market. All right, so question, what is the market trends right now? I would say personally that from my point of view, right now, the top topics is for sure autonomous driving. We will not stop on discussion what is real autonomous, because you know it's really tricky and it's really good point to discuss. But anyway, for sure, autonomous driving right now is the one who is in a trend. I would try to say in one phrase about autonomous, it's when companies try to make the more computing power in cars than horsepowers, as it was previously. The second trend will be about electromobility. So the point is that right now, nowadays, all automotive vendors trying to create the new platforms, which is like fully EV. It's right now fully EV platform without combustion engines. And for sure, right now, EV cars is a super popular area and super popular topic. And I would say it's the second trend from my point of view. And the third one will be the car mobility and connected cars. In one phrase, also, I try to accumulate it. It's when the cars trying to be the gadget and they provide, different usership models. In nowadays already and in the nearest future, it will be possible just do not buy car, and you can use it in the different models like leasing, car sharing, and everything about that. And as a result, all these three topics are pushing the automotive right now, and they like generating the vacancies, they generating the new technologies, and etc. All right, the next topic will be about EV. I know that it's still discussable for some reason, and a lot of people still not sure about whether let's agree that EV is electric vehicle. And a lot of people still not really sure whether electric vehicles is the future. And on this slide, I'm just trying to show you some potential plans for whole popular car makers and OEMs for until 2030. And at least from this slide, it's pretty clear that it's right now not only about Tesla and some small companies, it's already a serious game. So maybe it's not only the one future, but at least it's already the serious game. And I do believe that EV is a future still. If we're still talking about electric vehicle cars and market trends, what would be the trends? I did some research with our experience and also used some analysis from Deloitte and McKinsey, the companies who focused on that researches. I would say that a lot of business for us, like for engineers and for IT guys, will be in the charging station networks, because without charging station networks, it will be not possible to use fully electric cars. The batteries, the utilizing of the batteries also is a really important topic for sure. Hardware part, it's super important, to make some new type of batteries and etc. But in the software development, it's still a lot of work to do. My favorite one, and we will talk about that today, combination of EV navigation and autonomous driving. So all of you probably had some experience with navigation as a Google Maps, Apple Maps, and you know what is just to create the route. But for EV car, it's a little bit different. I will show you just one slide how it can looks like. But when you have the battery car in nowadays, at least for some period of time, like 5 or maybe 10 years, you need a helper. And navigation really can help you. And when you're just creating the route through like in a city or maybe long routes, you can see how far you can go. So your destination point, would it be reachable or not? And, with the battery car, it's really convenient to have such a feature because you can't fulfill your tank with the usual car. And when we are talking about combination of autonomous driving and EV navigation, the point is that a lot of companies right now investing to the autonomous driving development for algorithms to make the cars possible to drive by themselves through the road. And the question, would it be possible without EV navigation functionality? And it's what I'm trying to research. Let's talk about that in the next slides. The next trend and the point in the market is after charging. Right now, you need to charge and plug by yourself the car, which is a little bit annoying. In Europe, they even don't have already the people who come into you on a petrol station and helping you to fulfill your petrol or gasoline car. And if we will talk about autonomous cars, it will be strange. Who will charge the autonomous cars? Then I would say the after charging is really the topic, the big one for OEMs and automotive one. So we already discussed navigation, and one more super new, I would say, area is electric gyrocopters. Is it hard for me to say is it still automotive or not? But at least automotive companies like Daimler, they are investing in that market. And the goal is to create one more type of transportation system for us. Right. Usually when I am saying something about EV, for sure it will be at least one question about hydrogen. I like them, to be honest, but still, let's try to cover this question with my slides. At least, in effect, we can agree that the hydrogen cars, it's still EV, because they're using the hydrogen just to produce the electricity. But there is no modern, in nowadays, hydrogen cars, which are not using that logic when they are driven by electricity. So still, I would say hydrogen cars, it's kind of EV cars. But if we're talking about hydrogen as a source of energy, maybe in the future it will be a different picture. But, it's already the fact that to produce the hydrogen from clear energy, it is much more expensive and harder. And as a result, the cheap hydrogen right now is coming from the gas which is not about eco environment and etc. So maybe it will be some game changing and some new technologies, but with the current technology, I should say and state that hydrogen cars is still EV cars, and they still need batteries, and they still need EV engine. And to produce the hydrogen itself, either super expensive or it's not about eco style way. All right, so let's coming a little bit closer to technology. On this slide, you can see the future of automotive, and I would say that future is already in our day, maybe without some autonomous driving as a production, but already the whole cars connected to the clouds. They at least collecting the data, saving it to the clouds, getting from the clouds all data about navigation, I don't know, about charging, if it's EV, for example, about charging stations, because you will be not happy to come to some charging station which is broken. And I had such experience. It's not that cool, to be honest. So yeah, in nowadays, all cars connected to the cloud. And when it will be autonomous driving, I can see that it will be even more extensive communication between involvement of cloud technology to the automotive. Okay, just to explain you how EV navigation might looks like, to get some better context, here is just two super classic features. One of them displaying you the range, how far you can go, and second one is adding to you charging stations in case if your destination point was not reachable one. So, which is probably convenient. Couple of words about autonomous driving. Potentially in autonomous driving, there could be three areas of using the private cars. You just have the regular car and you can do not drive by yourself, and you can just put on the map the destination and go there. Cool, but in this case, to be honest, it's starting to be not a private car anymore. It behaves like a taxi, like autonomous shuttle, maybe with steering wheel. But the second one use case from my point of view is autonomous shuttles. And it's already a couple of companies which is really testing that approach. And I think in nearest future, we will see that. But the point whether this functionality will work without what we just discussed previously, without navigation, etc. And cargo, for sure, it even easier to implement the algorithms to drive only through German Autobahn or American highway. And I'm pretty sure that in nearest future, we will see the cargo cases going from A to B, from warehouse to warehouse. Right, so why I'm still thinking that I can see that a lot of companies investing money to navigation, a lot of companies investing to autonomous driving, and where I can see some interesting combination when they will combine both, because almost all of you have some experience with a regular taxi. Try to imagine if you will order the taxi and you would like to go in some from point A to point B. On the back end, it will be the logic. Then the managing of these autonomous shuttles should understand which shuttle is closer to you, then should calculate the route to you to understand is it reachable, and then also should calculate the route to point B, because you will not be happy to be stuck in the middle of the road, for sure. And then they, as a company, will be not happy if this taxi will be stuck in the point B, somewhere in, sleeping districts, for example, in Ukraine, where they simply don't have any charging station. That's why I can see the big future of these two areas, and I am personally pushing all of them and trying to convince that, to be honest, there is like fully autonomous driving is not possible without this EV functionality. It was fast, but I hope you got the main idea. I know that I'm quite limited in the time, and the last slide will be about, is there a Java involvement in automotive business segment? Because from my experience, when I'm talking with even my friends from Java area, they usually saying like, come on, it's about C and C++. I tried to visualize such a slide. We just discussed some segments for EV, for example. And in case if we are believing that EV is the future, but to be honest, it's relevant for all automotive, I tried to trace the whole technologies to that segments, and you see everywhere where Java is marked, for sure, it will be the Java involvement. One node, DevOps and Cloud, in my understanding, was especially DevOps, but yeah, some Java work is still there. And as you can see, it's a lot of Java words, which is leading us to the idea that it's a lot of Java work in automotive. Let's go super fastly about the main list. At least from my experience, I would say that in big data, there is some projects on the Java. Application development, for sure. There are a lot of backends for not only navigation, but for any services which is linked to the cars, they developed on Java. Mobile development, clear Java or Kotlin. I think it's still, Java machine languages, and UI UX. In case if, for example, as operation system is used in a car, even as a Google Automotive, then a lot of UI UX was developed and still developed on Java. And yeah, guys, Artem, maybe you can help me. I have one more case study. It's pretty interesting. Do I have a free time to explain that? Hope you can hear me.
Thank you, Denys, for this great lightning talk. We are a bit limited with time, so sorry for shortening your talk, but we have one question to you from the audience.
Right.
Is embedded systems still a C world, or there is a place for Java? Is there usable IDEs for embedded development except ERs and Kale?
Good question. Today I had a couple of chats with our Java engineers, and mostly it's still C and C++ world, but there is some projects for embedded for Java. Usually they are for a small, how to say, it's a smaller project, but yeah, we know and it's existing.
Thank you, Denys. It was great talk. I personally got some insights about automotive industry. And have a good day. Have a great evening. Watch.
Thank you. Same for you. Have a good one.
Fireside Chat. I hope you guys enjoy our build-up. So it will be fair to say thank you to a company who supported us and made this event happen. I'm talking about Intellias. Intellias is one of the biggest IT companies in Ukraine, ranked among the best IT employers by Forbes and Dole. And it's not a big surprise, since a human attitude is what Intellias stands for. Now you have the opportunity to join Intellias team very quickly. Okay, so now, cloud builders, it's time for Fireside Chat. Meet my colleague, Nicolai Parlog, Java champion, Java developer advocate at Oracle, and organizer of Ascento conference. He also writes, speaks, streams, trains, and consults about Java. Nicolai will be holding the Fireside Chat on the topic Modern Java in format of Ask Me Anything. So you can ask Nicolai about new Java features, Java release cadence, migrations, Java futures, particularly Project Ember, Panama, Valhalla, Loom, and so on. So prepare your question for Nicolai and ask them in Slido. Here, link is here. Welcome, Nicolai.
Artem, thank you for the introduction. Thank you.
I also should mention about the safe harbor that we do not represent Oracle company here in any way. So all meaning statements and assumptions are just my and maybe your personal stuff. So it shouldn't be treated as any commitments.
Yeah, that's how you can really tell that we work for Oracle. We have to say that. Funny story about working for Oracle. So Artem and I, we got to know each other like yesterday. So yes, we work for the same company, but it's a big one, and we didn't
Yeah,
meet it before.
yeah, we
I
didn't
think it was
met
the day
before,
before,
but
actually, right? It was Tuesday. Yeah.
I propose to start talking about modern and sexy Java. So let's start with some introduction. Maybe you can express your opinion about what does modern Java stands for.
Yeah, so
What is
I
modern?
mean, Java is quite a long and a history that had its ups and downs, and I think specifically after Java 7 came out, like it took a while for Java 8 to materialize, and 6 and 7 didn't have the biggest changes, and Java. I think people have been proclaiming Java dead probably since the 2000s began, but during that time, during 6 and 7, I think they had the best arguments, and so really like Java didn't do very well. And then I think the big change was really Java 8 with lambdas. It's not like like it's obviously not the biggest innovation. Other languages have lambdas, but Java showed that yes, it can evolve and it can pick up new features that are needed nowadays, that people need to write modern code, where you would not need like anonymous classes or tons of implementation classes somewhere for all your listeners, all your strategy patterns, where you could very simply just create some functionality in line and pass it on to an API like the Stream API, for example. And Java 8 saw great adoption. Like people really liked it, and it was phenomenal release. And then came the necessary restructuring of the undergrowth, I think. So with the module system, they went to Java 9, and a couple of changes that went there that made adoption of Java 9 a little bit tougher. But then also a lot of small changes that went into 9 that were really there were just a lot in total, like small language changes, very minor ones though. But there were new APIs and lots of updated APIs, and for example, new tools and new like JShell, for example. And then we had what else? There was more stuff. Oh yeah, right. Multi-release jars. That's one thing I like to mention because that's an interesting thing that got added in 9. Sorry.
As we touched module system, can we talk a little bit about it? Because we have a question. If there is use cases for Jigsaw somewhere besides libraries and frameworks development.
Yeah, sure. First of all, let me quickly finish that thought. So I think with 9 and then the new release cadence of every 6 months, Java was in a better position to just evolve. Not that much faster, actually. It's not like like the same amount of people roughly work on the same stuff. So it's not like Java tripled its development speed, but it just got a bit better. And then the regular releases made it easier to gather feedback on features. And so since then, I think really what modern Java means to me, basically 9 and later. So everything that happens with the new release cadence and uses some of the new usability features, and specifically what's coming up with like Loom and Valhalla that you already mentioned. Yeah, regarding the module system. So I like the module system, but I know that puts me at somewhat of a minority. So take everything I say with a grain of salt. But it's interesting to see that I feel like most people think like, I'm working on an app. It feels like a feature for library developers. And sometimes library developers express the same thought, but the other way around. Like maybe it's more like for application developers. So the value I see in the module system is generally if you're managing a larger project that consists of more than just a single jar. So that this does more than just, like I pull in a small dependency and then, write a couple hundred lines of code. As soon as you start splitting up in several jars, or you have a deeper dependency tree, I think from that point on, the module system does start to make sense. If the app is very small, the effort is very small indeed. And yes, then the benefits are also small, but I think it's still worth it to, from the beginning, think about the structure, think about what do you want to expose outside a module, which is like strong encapsulation, which I think is maybe the most important feature of the module system. I think like, I remember how often I was writing code and I was like, I want this class to be visible not just in the package, but also elsewhere in the jar, but please not to somebody else outside. I've been in this situation so often. And so to me, the value of the module system was immediately apparent. I can now finally do that. I can now finally have classes that are visible inside my entire jar, but nobody outside of it can touch it. And so strong encapsulation is definitely a very important one. And I mean, there are more smaller like downstream benefits, like you use it with JLink to create these runtime images or application images rather, that include your application code. There's a bunch more things that you can do, but really I think it should be seen as a tool to enforce a more modular structure. It doesn't make a code base modular. You still have to work to that. You still have to make sure that you cut a more code base in the right places, that you make sure that some things are a stable API that you want to expose within your project even. And to think those things through, that's not something the module system is going to do for you. But once you have done that, once you have thought those things through, then you can go back and say, okay, like now I'm going to put in the module descriptors, make clear boundaries between modules, make sure nothing happens accidentally. Like what happened a lot in a larger project that I used to work on was somebody had to implement a feature set. So, you have a bunch of stuff that is the actual feature set that is usable from outside that jar, from the rest of the project. But you have a bunch of other stuff that you need to implement it. But for necessity, they might also have been public. And then what happens a lot is that, other developers, they see that functionality that you just used as an implementation detail. And they're like, hey, I need that, or almost like that. So let me fiddle a little bit with it, and then I can start using it. And suddenly you had like a growth where things depended on one another that nobody really intended. Specifically, you start depending on internals of other jars that nobody really intended to be written like that. And now you can clearly say, I wrote this functionality. This is part of what's the public API of this feature that other parts of the same project can use. And then the rest is internal, meant only for within this jar. And I think that's a use case that, of course, cross-jar boundaries is more important for libraries and frameworks that get reused a lot. But in a large code base where you can up with dozens or maybe even hundreds of your own jars in just one project, it's also very important. It also communicates intent very well. So I think, yeah, there's a lot of value in those situations.
Maybe a great example of exposing unnecessary classes is misconsafe, which is going to be duplicated for several releases in a row, but still is accessible.
Yeah, I mean, unsafe is like its own special story, right? Like it's not just you shouldn't use this. It's also like actually you can, because it has like a private constructor that you're not supposed to call. But if you use the right reflection, you can still do it. So that was really like a little bit of an arms race going on between the JDK team trying to hide it and everybody else trying to use it anyways. And I'm not even pointing fingers, right? The reason why unsafe was not just encapsulated as it should have been by its name because it's in the Sun package. The reason why that happened was because for some of the users of unsafe, there is no publicly available API with the same performance characteristics. Often it's down to performance. It's very unsafe, hence the name. So that's why it's not great to use it. But there are certain use cases that you cannot, in a performant way, do otherwise. And that's why it got used. And that's why now slowly there's going to be replacements for these internal APIs. And slowly but surely, unsafe will basically become useless, because all of these features will have better, safer, and hopefully even more performant implementations. But I don't know the exact details on where we're at, but I think it will still take some years for all of this to unravel and for unsafe to go away.
You maybe are referring to Panama project, right?
Panama as well, yeah. Panama's not the only thing, but yeah, of course. They're also doing stuff where in the past, when you had to manage off-heap memory, often unsafe would be the way to go. And now with the foreign memory API that Panama has introduced, like it's in preview, so it's an incubating API for a long time already, and it always gets refined and it gets more crisper, is what the term that got used in an Inside Java podcast about that. And so yeah, Panama, for example, is going to take away some of the use cases from unsafe. Exactly. And that's also, by the way, where multi-release jars. Sorry. That's also where multi-release jars tie back into, which is if you're a library developer and you develop something for the old unsafe, and now Panama comes out and you can use the new API, you can still ship a single jar that on the new Java version uses the new API, and the old Java version uses the old API, and this way you can, as a as somebody providing a library, but also maybe just a company internal utility. You can use multi-release jars to use safer and more reliable APIs where they are available, while using the old stuff on old versions where you still have to, and thus give a good migration path and be like, you can already use the new stuff, and then in a couple of years I'm going to drop the old stuff, and that way.
Yeah, thank you. We have a number of questions from the attendees, and the first one is pretty generic. Maybe you can highlight the changes in Java release cadence, because there were changes.
Yeah, right. So in the past, the release cadence was want to have a big usually there's a big feature in there like lambdas or the multi-system, but also we want to go for release every 2 years. And every developer knows that that's at odds. Like, we want to have the big feature done, but also there's a strict timeline. Doesn't always work. Didn't work out that great. Like the multi-system, Java 9 came out 3.5 years, I think, after Java 8. So it's like that it happened. What is normal in software development? Things take longer, and then a lot of but it didn't go well because so much stuff was already done that could have been shipped earlier. And I think really that experience particularly really ingrained that, look, both of this, we need a big feature, but we also do it like every 2 years, where missing one release really hurts. Like, you don't want to wait another 2 years, so you just like push this one out just like half a year, and then maybe we're done. So going to the new release cadence, which is every 6 months like clockwork. So it's, I don't know the specific algorithm that determines this, but it's, I think, like the second or third Tuesday in March and September, something like that, right? So it's always in the middle of March and the middle of September is when the new Java versions come out. And that clockwork is really helpful. It means 3 months before the release branch, or it's a fork actually, but you can think of it as a release branch, is cut. And so everybody just develops their stuff, right? When Panama has something that is done, it merges it into main. When Valhalla or some simple API change, or maybe another language addition from Project Amber, when those things are done, they get merged into main. And then at some point, 3 months before the release branch gets cut, and everything else that then goes into main will just not be in the release. So the release can stabilize and be shipped. So that's like that clockwork really helped a lot. And if it hurts, do it faster. Work 100% here. Like the team often says internally that things got so much easier now that you don't have to bother with that anymore. You don't have you don't have to, it's not fiddly to plan ahead. When the release is going to be, when the release branch is cut, when the different release candidates come out. All of that in advance, and it's thus very easy to not waste time on discussing that and figuring that out. So that's really has been a boon to the Java development, I think.
And by the way, there is still change in the release cadence since Java 17. We do not wait now for 3 years. We will wait for 2 years for long-term support release. So the next LTS will be Java 21, right?
Yeah, so
Java
that's
21st.
Like technically that's like it feels very related, but technically it isn't, because like the release cadence of Java, of the Java language specification and of the JVM specification and of the reference implementation which is the OpenJDK, all of that is something that exists within the OpenJDK project, within the community. And then of course in that community are individuals who contribute. Most of them are paid by companies, for example Oracle, but of course also by other companies. And this mostly OpenJDK is a community of individuals working on the OpenJDK, of course funded by companies. And then the companies on the outside of that process, they then build their own support and contract models and whatever on top of that. And there, there's a wide variety of projects of companies doing that. So technically, every company can say, we give you LTS every 17th release or every prime number or whatever. Like, everybody can come up with their own idea of how to support this. But then again, of course, it still makes sense to align on a similar cadence. It just makes it easier for customers. It also makes it easier for the individual companies to maintain, because then there are shared branches in the OpenJDK and all of that. So there's a tendency to find one common denominator. And that used to be 3 years between 11 and 17. And then, maybe that's a bit too long. Maybe that's a tad too long for adopting a faster cadence, because it turned out that many customers or companies using Java did in the end decide that they will go from LTS to LTS, which I find a bit sad. I don't think there can be good reasons for that, but I think more people could do it. I don't think those good reasons apply to as many companies as are sticking to that release cadence. But that's a different topic. Now the idea is, well, if they stick to LTS every 2 years, that's a bit easier for them. And also means if you start a new project and it's going to go into production next year, you can, maybe we can already, well, next year not, but if we start in the end of 2020, you could maybe already start on Java 19 and then guess like, by the time it comes out, it's on 21. So it makes it a bit easier to plan for the next LTS and, piggyback on that one if you want to stick to LTS.
And by the way, what do you think? There is more than one company that develops JVM and releases it and provides, like Amazon, Azure, Google, and so on. And what do you think? Are they also aligned to the release cadence with LTS? I mean, what does it mean for them? Do they need to stick to LTS cadence?
Yeah, so technically, each of these companies can do whatever they want, right? But as I said earlier, there is like a tendency to align on a shared schedule. And I have to say, I don't know where that proposal is technically. So if I remember correctly, Mark Reinold proposed this, not so much announced as proposed this by the time Java 17 came out, I think during the same days, and proposed to change the LTS cadence, or said that Oracle is considering that. And then I think we're waiting for feedback from other companies. I have no idea where that process is, though. So maybe feedback was already provided and it's already settled. I can't really say. Maybe I should look into that. But I would guess that I think that it's fair to assume at this point that it's probably going to be 21. Then again, just waiting. Like, it's not that important probably right now because 17 just came out. So waiting for another, I don't know, half a year before before making a decision that is based on a 2-year versus 3-year LTS is probably still plenty of time. Right. So yeah, I can tell. Like in the end, if you are using a certain JDK from a certain company, the things you could probably do is A, contact them and ask them about it, and B, decide what you think would be best for your project, and then find a company that gives you the support that you need. Support is also a vague term. Like, support doesn't always, like, what does support mean? Does support mean there's a bug fix will eventually show up, or does support mean there's somebody I can call in the middle of the night if my JVM crashes? So not the same level of support. So you should decide what level of support you need, what intervals do you need, and then who do you trust most to provide that, and then go looking for that company that fulfills those criteria.
Okay. We have a question from Ruslan about records. He wondered how to attach a builder to a record. What do you so that you can shift from entity to DTO in the right way, and while sealed classes. Maybe we can start with the record. How to use builder in it.
Yeah. So that's actually a good point. So I don't have quite the builder issue myself, but I really like static factory methods. I use them a lot, specifically for like data-like stuff like records. So for example, the datetime classes, they all have these off methods, which you can like you give them a string and then you get back like a local datetime or something. I really like those static factory methods. And of course you can add them to a record, but the constructor is still publicly visible. So it's a bit, well, so what's the point then? So that's something that I encounter myself. And with builders, there's no support there in any specific way. If you want to have a builder for a record, what that means is you will probably ask your IDE of choice to generate the builder. I mean, you can type it by hand, but you don't have to, right? So you would have a record which has, like, let's say 3 components, and then you would generate a builder class that has 3 fields, 1 for each component, and then a setter method that returns the builder. And then in the end, you have a build method that just calls the record constructor. So you have to create all of that code, either type it yourself or have it generate by an IDE. And then still, the record constructor is still available. So was that really that much of a benefit? So it's like with the static factory methods, although the builder has more advantages than a static factory method. But with the static factory method, I actually gave up. I was like, okay, I'm done with records. Apparently, I'm going to use a constructor now. So there's that. So there's really no specific integration. You basically have to do the same things you would do for a regular class.
So you can just create a public static class within the class of the record within the same file,
Yeah.
and do it manually. Just create manually the builder, right? But there is no
Yeah.
automation for this process. Maybe some
Yeah, exactly.
frameworks
There's no-
or libraries provide this. I'm not sure. Okay, we have a question. We have a,
There was a question about
lot of
entity and
questions.
DTOs, right?
Sorry?
There was a question about entities and DTOs, right? And records and how that works.
It's like a shift from entity to DTO, because
Yeah.
you know, for entity, it's there is another question from the same also, why sealed classes? And maybe I can rephrase it. What is use cases for you for sealed classes? Because you know, they just prohibit to create some inheritance, and it's again a kind of use cases for module system, for libraries, for frameworks developers, but what is used for regular developers?
Yes, so yeah, 100%, although that will require a certain change in perspective. So let's say you have a customer relationship management system, right, that you're maintaining. So you probably have a class that's called customer. And so then maybe you want to attach, maybe you want to you need to deal with the customer when writing invoices, or when logging them in, or when, I don't know, sending them emails. So there's probably plenty of ways, because it's a central class. That's the idea here, right? It's a central class that's essential for your entire system. So probably many parts of the system want to interact with it and do stuff with it. And that adds that introduces this problem that potentially there will be feature creep, that potentially you're going to start adding all of these methods to customer that don't really match one another. Yes, they're all related to the customer, but other than that, what has that sending an email with, you know, billing, creating an invoice, that's nothing to do with one another, right? They just end up on the same class in this hypothetical, because they all deal with the same class. So what you would do to avoid that would be usually to use the visitor pattern, to say, okay, look, we're going to have like just the customer class, which is just the core of the functionality I need. And then in the billing system, I'm going to write like a customer visitor that I can pass maybe to a list of customers, and, or, you know, because there can be other subclasses of customers maybe. And then it will know how to write an invoice for the customer, stuff like that. So a way to extend the functionality of a class without adding all the methods on the class is usually the visitor pattern. Now, the visitor pattern has its value, obviously, but it's not great. Like, it's very indirect. It's not easy to see what's going on, and it's a lot of extra machinery you have to set up to make it usable, or to use it. And what pattern matching and sealed classes, these really go together. What they can do is something you would not have done in the past, which is basically, well, if you give me a customer, and it can be one of these three subtypes, and I need to write a function that, you know, creates an invoice for customer, but, you know, depending on the subtype, I do something differently. I don't want to add the method to the customer interface. Instead of using a visitor pattern, what I can do now is I can just say, okay, switch over the type of the customer that I have. Now, in the past, you would not have done this, because, like, it feels wrong. It just feels wrong to assume, well, I know that the customer has these three subtypes, so let me just write an if-else chain. If it's this one, do X. If it's that one, do Y. Like, my skin crawls just thinking about it. But the thing is, with sealed classes, you know the subclasses, and also the compiler knows the subclasses. You express it clearly. You write sealed class or sealed interface customer permits ABC. And then, you know, only ABC are allowed as subclasses of customer. And then you can actually use that information to create a nice switch. You wouldn't use an if-else chain. Instead, you write switch over the customer. Case it's subclass A, do this. Case it's subclass B, do this. And then what you get for that also is a completeness check, because the compiler knows that there can only be ABC. So if you only list A and B, the compiler is like, wait, you're missing something. That's not right. So you have to list ABC or AB default, of course, that works as well. But you can decide to have their list case A, case B, case C. And if then in the future you add a third implementation, and you would, a fourth implementation of the interface, then you will get compile errors everywhere where you used to just switch over the first 3 types. And that's something that the visitor pattern also does for you. The reason why you don't want to do the if-else chains and why you do want to use the visitor pattern in the past is because when you use the visitor pattern and you add another implementation, you have to go through a couple of steps that in the end will lead to compile errors in every visitor. And that's intentional. It forces you to go to every visitor and update it to deal with a new type. And the pattern matching with sealed classes will do the exact same thing. It will force you to go to every place where you switch over the type and then add that additional case. So what that really does is basically lift this thing we built with the way that the Java dispatches methods and in a couple of classes and interface you wrote to that, and we lifts that into the language and says, okay, what the visitor pattern really does is it switches over a number of types, and what sealed classes together with pattern matching now does is the same thing, but more elegantly, much shorter, I think much more readable. And while there will probably be some specific cases where the visitor pattern cannot just be removed, I think in most cases it will just be gone. Small asterisk, sometimes you use the visitor pattern to basically pass the functionality to a data structure, and that data structure will then iterate over its internals. So that part of visitor pattern is still useful, but I would expose that in a different way. For example, you can have a tree you call iterate and returns a stream of nodes. That, for example, then each node could be this class or that class. I wrote a long blog post about that and got a little bit of heat because I was like declaring the visitor pattern to be dead. Not everybody agreed, so that's my point of view. But I think it's safe to say that a lot of instances of the visitor pattern can be replaced by this.
I think your point is clear now, and it's a great example. I personally appreciate your answer. So, yeah, sealed classes are going together with pattern matching, and it's for sure a great illustration for this. We have a question from Sergey. Can Java be considered as a language for writing desktop applications? For example, port and GRE and show it along with project files into the installer. So what do you think? Java and desktop.
Yeah. So I mean the Java. I mean, so Swing. I don't know. I guess like AWT and Swing don't see a lot of development. I guess. I mean they're pretty mature as well, but specifically Swing. But I don't think it sees a lot of development. So if you feel like, well, I can't build the desktop app that I want with Swing, then it's probably doesn't make sense to wait around for Swing to get the features that you're missing. I'm a little bit guessing here. I don't actually know how many people work on Swing, but I wouldn't be surprised if it's not many. JavaFX, I think, has a little bit more of a drive. It's generally more modern. It's more approachable. When I worked with it years ago, I actually liked it quite a lot. The reason I'm called NipaFX is the same FX as in JavaFX, by the way. So I did like it a bit, working with it. It missed, back then I think I felt it missed, or heard, it had missed some features that you would have in Swing. But I also feel like JavaFX matured, so there is that. So it's not like you can't write desktop apps with Java. I don't know, still doesn't seem, I don't know how many new projects start. I know of several projects that have a client server structure, but the client is a thick client, it's like a Swing client, that are moving towards just writing a regular Java backend and then have a JavaScript, HTML, CSS frontend. I know of 2 large projects, and I basically know of no other project. I know nobody who's like, well, we did like a front end backend split with Java on the backend and HTML on the front end. I wish we would have used JavaFX or Swing. So I don't know. I think it really depends. Like when you know a specific use case, I would really look into whether the Java desktop functionality provides what you need. But I think chances are that the common split between Java backend and like an HTML JavaScript front end is probably widely used for a good reason. So yeah.
I think besides the UI and UX frameworks, which are there is not much variety for Java at the moment. There is also another question that Java requires runtime. And if we're talking about desktop applications, you should ship your GRE together with your application. And there could be some licensing questions. And by the way, we can probably highlight the changes in licensing for Java. So starting Java 17, there is some change. Could you please highlight it to our audience?
Yeah. So first of all, I described earlier how there's the OpenJDK community, and then there's basically companies that are, well, of course, funding the people working on the OpenJDK, on the project, on the code base, are still separate entities. And what we discuss now is just for Oracle, right? So Oracle decided that the Oracle JDK is going to have a new license. So Oracle provides two JDKs. You can get the Oracle Open JDK, which is GPL licensed at jdk.java.net. You can download that. That's always the current version, and that's the thing that that's the Open JDK built from Oracle. If you find companies that say we built the Open JDK, then I'm not going to say exactly, but like in spirit at least, I think there should be bit for bit the same thing, like same license, and maybe some names are different somewhere. But most like projects building the Open JDK do exactly the same thing that happens on JDK Java.net, which is the Open JDK built by Oracle. So there's that, and it's GPL license, so you can do whatever you want with it. So that's and class path exception, of course. And then Oracle had in the past, you had to have like a Java SE subscription to use Oracle JDK in production. And now Oracle has a new license where you can use the Oracle JDK. So that's not on JDK Java.net. That's oracle.com/probably Java something. That's where you can get that one. And that now is for free for the it's for free in production, I think, for all the versions. And I definitely know that for the LTS versions, it's going to be free for 3 years. So the idea is you can pick up the Java 17, the Oracle JDK 17 build, and use it for 3 years in production for free. And then after 2 years, probably 21 comes out, which is the next LTS. And then you have like a 1 year overlap to change. Now it's free to use in production, but I think there's some limitation when it comes to like reshipping it in a sold product. And I'm really not a lawyer, so if that's an important decision for your project, do check with a licensed expert, which is once again not me. But you asked about shipping with the JRE, right? So the Java runtime environment is not really a concept anymore. That ended with Java 9, so you cannot find easy downloads of that either. You can create your own, since everything in Java 9, at least within the JDK, is a module. It's really easy for you to just create the runtime image that you need. You can either build the entire thing, which contains the compiler and the Java doc too, which is probably not what you want for a customer app. If your app is fully modularized, it's really easy. You just say you can find out what your dependencies are very easily and then just create that. If your app is not modularized, you have to do a little bit more work. You can use tools like JDEPs and figure out what your dependencies on the JDK are. And then you can figure, okay, so it's these 5 modules. You pick up JLink, you tell it, build me a runtime image that contains these 5 modules. And then JLink isn't stupid. It puts in all the dependencies of those modules as well. So, they actually work. And then in the end, you get a runtime image that contains the minimum amount of modules that work to support your application. And what you can do then is you can then ship that to your customers. Or you can include your own code. If it's modules, it's fairly simple. If it's not, you have to fiddle a bit. Now there's also JPackage, which I think was introduced in 14, which allows you to create operating system specific installers. So you can give people like an MSI file on Windows, or I don't know the Mac stuff, but yeah. So you can give people like specific installers that are like native to the operating system. And so that would be, I think, the common way to ship that. So really, like, do not rely anymore on your customers having a JRE or a JDK installed. This has a big upside that you can now control which Java version your customer uses. But it also comes a little bit with a downside, because if you ship your customer a Java 17.0.1 release, and then 17.02 comes out, it has a security fix, you should then make sure to deliver your app again with the new Java version, right? Because you don't want to have your customers sit on an outdated version running your app on a JRE that has potential security risks. So while it has like the big upside that you control the JDK, it has the downside that now you must JDK that you ship.
Yeah, and I think also about another option, maybe compile your application with Graal VM into native image, right? So it could be shipped without requirement to have a JRE on the machine.
Yeah, like if you use Graal to create a native image, assuming that all your dependencies play ball and you don't use too much fancy, like bytecode manipulation at runtime, then yeah, you also get an executable which is operating system specific, and it just runs, right? You don't need any extra, and it runs. And specifically, it boots like super fast. Like if you want to write small tools in Java, which another feature, by the way, that was added in Java 11, which is really cool. You can now take a single source file and just throw it at the Java command, at the Java launcher. So without having to compile it first, you give it to the Java launcher, it will compile it in memory and then run it, which is great, because if you're one-trick pony like me who can only do Java, well, now I can do a little bit of like the web stuff, but I'm still not great with like C, Python, or Bash. So what I can do now is I can write a script that does some small things on my system, like just in Java, which is great, because Java now with streams and the file IO stuff that got added, like it has really some handy methods that makes it really cool and fairly straightforward, specifically if you know it already, to write a well-to-maintain script that does a bunch of things on your file system, as I said, or whatever. And so you can write that in Java and just throw it at the Java launcher. And if you then figure out, well, the script should just run a couple milliseconds and not take like a couple hundred to boot up the JVM, then you can take it to Graal and create a native image out of it. And then you actually get like an executable on your operating system that boots like this. And then I think it's a JBang that makes all of this process a bit easier, that also includes the Graal. So the JBang, by the way, unlike the other projects that I mentioned so far, are not part of the OpenJDK. That's done by the community. I think his first name is Max, but I think I forgot his second name. I hope I'm right with that. Anyway, JBang, great project. Check it out. While you're at it, by the way, check out SDKman, which is also a great project. So with JBang, you can easily start writing these scripts, and when you're done, you throw it at Graal, you get a native image, and they launch really fast. So I think really that's also part of what modern Java is. It's not just, which is already quite a big chunk of what code is out there, but it's not just the language for Java backends. It works in education, it works for scripting, it works for small projects. It's not something that you pull out only when you have to write like a million-line a server backend. Like, it also makes sense in different situations. It's really versatile. It's becoming more versatile with Project Panama, making it easier to interact safely and fast with native code, makes it much more viable in the machine learning space, maybe in the embedded space too. I don't know that very well, but that's surely something that could be considered. And then it works great. Like Valhalla works great with it as well. We have these value types that really integrate well with Panama, because you're probably going to interact with systems that have different primitives than Java has. And nowadays, you would always map that to the few Java primitives that you have, and you can't really make use of something very specific, like an int that is only positive numbers, right? So there's like specifically machine learning, as far as I understand, there's a lot of primitives that are very specific to that space. And at the moment in Java, you cannot really map efficiently to other small data structures or small primitives, but Valhalla will make that possible. So that's also, it opens up a whole new field of things where you can maybe write like the same high performance machine learning code, just stick to this example, with Valhalla, or you can rely on an existing implementation, use Panama, use the foreign function interface to very simply and, as I said, efficiently interact with it, and then use Valhalla to create all of these specific primitives that you need to interact with that without a loss of performance where you map everything to a long just because you don't have another type available. So I really think like the future in that sense is bright, and I think the last half of the 10s, so of the recent decade, was the time that Java picked up speed again. But I really think like the biggest changes on the surface level will be what comes next. Will probably be Valhalla, that also opens up Java to more use cases. I mean, text blocks are amazing, don't get me wrong, but with text blocks, you're not going to do something that you didn't do before. You do the same thing, just it's easier, more readable, more maintainable. That's an incremental improvement. But I really think that Loom, Valhalla, Panama, they will open up entire new use cases for Java. Will make it much more versatile than it already is.
Yeah, and talking about Valhalla, we actually are waiting for value types whenever they will be named, and there will be a second phase for the implementation for them. As far as I know, there should be something like collections of such types. What do you know about this?
Yeah, so I mean, Valhalla is huge, right? Like there's like it happens on so many different levels. So in the language, you want to be able to say, well, this is my own kind of int, like the int that only has positive numbers, or this is my own point class that has an int x and an int y coordinate, but I really want to treat it like a primitive. Like you could think of that for currency amounts, or for just general units like lengths and everything, right? You don't want to have like, well, what you want to have is you want to have the abstraction of a class, which is public class length, which has like a unit and the amount of length. But you also would actually prefer to have the performance of a primitive, because in the end, a length is really just a number. So if you want to have that performance, then creating a full-blown class, that's like a trade-off. You have to decide what is more important. I would always say go with the abstraction first. But if you figure out later that it's not performant enough, then you have to rip it out and write code that is not the code you wanted to write. It's not the most maintainable code that you had in mind. And that's, of course, a downside.
Mm-hmm.
And so on the language level, you want to have Valhalla there to be able, like, don't worry, you can now create your value class that looks like a primitive and acts like a primitive. And then it reaches all the way down to the JVM, because then you want to have actually those performance improvements, right? Now you want to make sure, you want to have the benefit that your point actually does behave more like an int than like an integer, right? Like a capital I wrapper class integer. So there's that aspect. And then there's also the part about generics, which is probably where you went, right? Like if you have an array list of upper class point, then you have an array list of just pointers pointing to your instances. Probably point is a bad example because of the pointer, but you get my point. Wait. Yeah, just making it worse. New example, you have an array list of integer. What you really have is an array with pointers to all the integer instances all over memory, which is not great for a ton of reasons. Those are performance reasons, don't get me wrong, which are always not the most important part, but they can become quite important down the line. So that's not great. You don't want to have that. What you would like to do is have an array list of int, which just has like the integer ints back to back, just the 32-bit integers in that array, no pointers anywhere.
Yeah.
And we don't have
by value.
Yeah, exactly. And we don't have that, and that hurts, but it doesn't hurt that much, because really, do you want to have an array list of integer? I mean, like, why though? It's not like integer is a great abstraction. I think I rarely want to actually have an array list of integer. But if we now start creating points, and I don't know, what are all our own abstractions as values, now suddenly the use case for putting primitives into generics increases a lot. And now would really be bad if the JVM would be like, you know what? You can create a value class that is a point, and now we treat it like a primitive, and you get all performance benefits. Unless you mix with generics, it immediately falls apart. I mean, that's a bad story, right? Because we always want to use generics to make the code more maintainable, more usable, and more reusable. So it will be really hard to avoid generics entirely, just for that. And so that means we want to have the situation where you can actually create an array list of int, and then have it as an integer array, and the same with the array list of point, which just embeds the XY coordinates of your point into the array. And that's something that's going to come after. So first, it's going to surface in the language, and then that opens up freedom for the JVM to optimize your code. And then those optimizations will probably take a bit of time. And then the second part that surfaces in the language is the generics part. And then that will show up in the JVM as performance improvements. So we can expect to first be able to declare these things with basically like performance promises down the line that will then probably materialize over many releases. Like every Java release gets a bit faster for this reason or another. GC gets improved, the JVM as a whole gets improved. So there's always these gains. And specifically when something is new, initially the gains are the largest, right? Like the garbage collectors, I mean, they still see improvement, but they're also like years, partially decades old concepts and code. So of course, a lot of potential has already been pressed out of it. But when lambdas were new, for example, there was a big change improvement in performance in the first Java 8 minor releases. And probably I would guess something similar will happen here, that the value types that you can use in the language will open up performance improvements in the JVM. That will then probably be, initially there will be I guess more improvements, but then there will keep coming improvements, just like probably on a smaller scale. Just because, at least that's our understanding. Maybe I'm wrong. Maybe Brian is watching this and Brian gets and he's like, no, you're wrong. We'll just get all the performance improvements at the first release. I would personally be surprised. But yeah, the JVM details are complex, and I'm not expert in that at all. So take what I just said about performance with a grain of salt.
Mhm. Nicolai, we are a bit limited with time, so we will have time just for 2 more questions. I'd like to select the one which is about garbage collector, about new Java garbage collector. Can you highlight some insights about it? What does it provide to the developers?
Not really. So
It's actually not new since Java 17, yeah, but
I mean, there is ZGC out there, there's Shenandoah out there, there is G1. So there are a bunch of garbage collectors being actively worked on. Parallel collector also sees improvements all the time. And to my understanding, a fair comparison is if you do batch work, like if you don't mind pause times, if all you want to have is like the most throughput you can have, I think Parallel Collector is still your best choice, because it's just like, it doesn't care. It can pause the world for like 10 seconds and do its thing. And if you do like a batch work every night, running across like a ton of database stuff and pulling things up, who cares? If you want to have a web backend, you probably don't want your 99 percentile wait time to be 10 seconds because Parallel Collector was like, I got to do this now. So that's where these other collectors come in. And yeah, like that's really all I can say about that. There has been a blog post. Maybe we can share that after the show by. Now I don't even come up with the name. Let me at least look up the name because that was a great one. Yeah, Stefan Johansson from Oracle as well. He wrote a blog post about. Is there a chat here? Wait, let me see. I don't. Oh, there is one. Look, I'm just going to write in the chat here. Maybe you can get it to the viewers. He wrote one blog post about the performance improvements between Java 8, 11, and 17 in Parallel GC and G1 and in ZGC. And what you see there is things get better. That's really all. And I think for the average developer, it's probably not that important, but somebody on the team should probably know a bit more about garbage collection and make sure that you pick the garbage collector that best fits your project. So you have like a 2-person team, you have 50-50 chance that that's going to be you. But if you work like on a larger team, not everybody has to be a GC expert, but somebody probably should be on a larger team to make sure that, as I said, that you run the GC that makes most sense. It would be great if you have like performance benchmark suite that you can just like run a battery of tests and then get some certain benchmarks out, like what is your 99 percentile latency and all of that, and then just try with different garbage collectors and figure out what works best for you. So if you have that chance, that can be a very healthy exploration. It can make your app more performant for the customer. Maybe if you're running in the cloud, it could lead to the fact that maybe in that situation, like because the pause times are slower, at least like in the extreme cases, maybe you can even shut down certain instances and save money. It's actually a good chance that with newer Java versions, you can do that anyway, because they also get more conservative on memory consumption. Like generally speaking, below the surface of the language and the API, there's also a ton of improvements going on. They are more incremental, but they do add up. And specifically between 8 and 11 and 11 and 17, you can really see benefits of that. Then there's also JFR event streaming, which makes it easier to observe what's going on the profile of your application. So there's a lot of tools that have been added that should give you just performance improvements on the one hand. And if you're running in the cloud or even on your own premise, that often translate into saving money, right? So if you have like 10% less memory consumption because of a Java update, hey, good chance that you can save 10% of the money on your cloud bill. So that's definitely worth exploring as well. So I really can only recommend try to update to the newest Java version. Go to, if you're still on 8, go to 11. If you've done that, go to 17. And if you are on 17, I would recommend trying 18. I think there's a good chance that you can stick from 18 all the way to 21 without having to go back. I mean, that's a horrible case to have to downgrade. But I don't think that like the chances that happens to your project are very, very slim. Like there's not like Oracle just randomly goes with a shotgun through the code base killing APIs. There's like finalization, for example, is currently being deprecated for Mover and Security Manager. You should be aware of those things. And if you are, and you think like that's not going to be a problem for you, I see no reason not to stick with each individual release as it comes out. It always gives you the best JVM. It gives you the newest API and language features, which make your team hopefully more productive. And it makes everything smoother, right? Like if it hurts, do it more often. Doing a big update every 3 years is probably more trouble than doing a small update every 6 months. But then, of course, like if you have an application server, for example, that they might stick to LTS releases. So I'm not saying like, I said there's no reason not to do it. I want to say there's no reason not to try it. Like if your apps, if your dependencies don't play ball, then there's nothing you can do, right? But I think you should really carefully consider it and give it a real chance.
Nicolai, I would be glad to speak with you for a longer time. And there is a lot of questions left unanswered yet, unfortunately, but we're running out of time. So, Nicolai, thank you for the amazing Fireside chat. Your experience is unbelievable.
Thank you, Artem.
Thank
Thank
you.
you for having me and for the great moderation. By the way, if the audience wants to reach me, there's my website is nipafx.dev, and there's a bunch of links up there to Twitter, to a Discord. Reach out to me in a public forum, and I gladly see whether I can help you out, answer any questions that were left unanswered, give you links to if something I mentioned maybe. So yeah, we'll always run out of time sooner or later. But if you can find me elsewhere, maybe at Java Zone in next week. If you can find me elsewhere, just flag me down, ping me, talk to me. I'm always glad to be helpful, or just to talk.
Thank you, Nicolai. Yeah.
Thank you as well, Artem. Bye.
Yeah. Have a great day. And guys, our friendly fire is going out, and the meetup is close to the end. So we want to say thank you to all participants who spent their time here with us, to attendees, speakers, organizers, and our sponsor Intellias. Thank you. And we really want to know your feedback. So here is the link in the chat to the forum where you can share your experience. And our next build up will be better and more useful to you. So saying goodbye to all Cloud Builders fellows for today. Stay tuned for new achievements. Bye. Bye.